Good morning, everyone. My name is Xia Jia. Today, I'm going to present about the analysis of a simple RLC AC source electric circuit. So, this is our circuit. We need to find the voltage, current, power, reactive power, apparent power, and complex power in the circuit by using source transformation.
Hi, I'm Winnie. So I gonna explain about the calculation. So the method that we choose is source transformation. So let's look at our circuit. So we're gonna transform this, which is in parallel, into this, which is in series. If we look at this, we're gonna transform the current source into the voltage source. So first we write a current source in the polar form. So it's 8 ampere in the 0 degree. Okay, we know that V is equal to IR. So we got the I here and the R here. So we times it and we get 40 watt with a 0 degree here. Okay, next we calculate the frequency. We know that omega is equal to 2 pi f. So the omega is 200, and we calculate and find the f. So we get f is equal to 31.83 Hz. Next, we find a ZL. The formula is ZL is equal to J omega L. So omega we know is 200 and the L is 5 millihertz. So we times and we get J ohms. Next, we calculate the ZC. So ZC is equal to 1 over J omega C. So the omega is 200 and the C is 1 millifarad. And we calculate and we get negative J 5 ohms. Next, if we look at this, we can see two resistance. So we find the RTH. So we plus 2 of it, which is 5 plus 3, because he is in series. So when resistor in series, we plus it. So 5 plus 3, we get 8 ohms. So here is our final circuit.
The current is equal to voltage divided by the total impedance. So the voltage is equal to 40 with 0 angles, and the total impedance is 8 plus J minus J5. So we will get, after we calculate, we will get 4.47 with angle of 26.57 ampere. As the circuit is in series connection, so we will use voltage divider to find each voltage drop. First, we're gonna find the voltage drop on resistor 1. So VR is equal to 8 divided by 8 plus J minus J5 times the source voltage 40 with angle of 0. Then we will calculate. We'll get 35.78 with angle of 26.57 watt. Next, we gonna find the voltage drop on inductor. So VL is equal to J divided by 8 plus J minus J5 times 40 with angle of 0 equal to 4.47 with angle of 116.57 watt. Then we see is equal to negative J5 divided by the total impedance and then times the source voltage. So we'll get 22.36 with angle of negative 63.43 watt. Okay, then we're gonna find the compressed power S. So the formula is Vs times Is conjugate. So Vs is the source voltage, and then Is is the source current. So source current will be conjugate. So the angle will change the sign from positive to negative. Then we will get two forms of answer. So first is in the polar form, and then we will get a rectangular form. So first we have 178.8 with angle of negative 26.57. So this magnitude will be our apparent power S. Then 159.92 will be our P, which is the real power. Then minus J 79.98. So this will be our Q, which is the reactive power. So we just take the magnitude only. So now you see we will have real power equal to 159.92 watt. Okay, and then we will have reactive power Q equal to negative 79.98 watt ampere VAR. And then S, which is our apparent power, will be 178.8 watt ampere.